Okay, now, we're at the point now where we want to just find out what the derivative of sine is, what the derivative of cosine is, and then later on we'll look at the others. But I want to start off with just with sine and cosine. Now remember a couple of things here, that this limit, the limit as x goes to 0 of sine x over x, you remember what that is? Yeah, 1. Now, this is very important. That limit is 1 if x is in radians, right? But if x is not in radians, that limit is pi over 180. So what I'm about to show you in deriving the derivative for sine and cosine is dependent upon us being in working with radians. Because if we're in degrees, this limit is a little bit different, and that's going to make a difference, okay, in how we think about the derivative. Now also remember there was this other one, the limit as x goes to 0 of cosine x minus 1 over x. Now remember what that was? 0. And of course it could be 1 minus cosine over x. It doesn't matter. But these two limits are what we need to be thinking about. Now a couple of other things that I want you to recall. Remember back when you were in trig, you learned what the sine of alpha plus beta is. Okay? So remember, it goes like this. It goes sine alpha cosine beta, right? Plus cosine alpha sine beta. You need to know this, because what I'm going to do is I'm going to have you derive the derivative for sine and derive the derivative for cosine. And some other things, the product rule and the quotient rule, and then you can get your deriver's license. That enables you to use these formulas. But right now, really, you need to be able to use the difference quotient. Okay? Now, you remember that. Now, also remember cosine. Cosine alpha plus beta is the cosine square. Well, let me actually, hang on, what am I doing? Okay, so we have cosine alpha, cosine beta, minus sine alpha, sine beta. Okay? Okay, so we're going to utilize those things. So here we go. So let me put these in a box. And now let's see if we can get the derivative for sine. Okay, so here I go. d dx sine x. Okay? Now, we go back and we put this in using the difference quotient just like usual. This would be the limit as delta x goes to 0 of sine x plus delta x minus sine x over delta x. Okay? So we always go back to the derivative. Now, I want to expand out the sine x plus delta x. That's what I want to do now. So here we go. We got the limit as delta x goes to 0. So when you do this, this is the process. You're going to first of all put it in just a formula for the derivative. The next step is you expand it out. So this is going to be sine x cosine delta x plus cosine x sine delta x. And don't forget subtracting off the sine x. Okay, does everybody see that? So you put it in the formula for the derivative, the definition of derivative. Then you expand out the sign. You just make sure you expanded it correctly. I believe I did there. Okay, now I'm going to do this. I'm going to take this first and last term and put them together. Okay, I'll just put the first and last term together. Just kind of reorganize it. Okay, so we have sine x cosine delta x minus sine x. Okay, now what I'm going to do is I'm going to put those together over delta x, and then plus the delta x goes to 0, and put the rest of it, right? Okay, does everybody with me on that? Any questions about that, what I did? All I did was put the first and last term, gave it its own limit, and then I gave the middle term its own limit. Now, I'm going to do this. Notice that this sine x here, this first one, there's a sine x there and there's a sine x there. That sine x doesn't have a delta x in it. It doesn't care what delta x does. So let me just factor out the sine x, and I'm not even going to put a limit there. I'm just going to factor it out. So there's sine x, and now we've got the limit as delta x goes to 0. Ah, this looks familiar. Yes, sir.
Wouldn't it be negative sine x? Because, you know, if you let delta x go to 0, you're having cosine delta x becoming, and that would become 1. So then would it be sine x minus sine x?
Well, I factored out the sine x, right? And I just put it out front. So there was a sine x here and a sine x here. And I just brought them out front. And then what's left there is the cosine delta x minus 1 over delta x. Now, on this other one, I'll do the same thing with cosine, because cosine doesn't give a hoot about what delta x does, because it doesn't have a delta x. So we've got sine delta x over delta x. Ah, now we can evaluate these limits. Okay, this first one, what about cosine delta x minus 1 over delta x? Yeah, 0. So this whole thing is 0 plus cosine x times 1. Ah, cosine x. That's right. The derivative of sine x is cosine x. So you want to put that in your knowledge pot. That's an important little concept, an important little thing to remember, right? Derivative of sine is cosine. Any questions about that? You would think that, but no. Not exactly. Not exactly. Okay, so now what you're going to do is you're going to go through that process. Next time, I guess Wednesday, you'll go through this process. We'll have a quiz, power rule problems, and then I'll say derive the formula for the derivative of sine. Then I'll say derive the formula for the derivative of cosine. So if you look at cosine, now if you can do it for sine, you can do it for cosine. But it works out just a little bit different. So here we go. We've got the limit. So this is the first step. You put it in the formula, in the definition. So we have cosine x plus delta x minus cosine x all over delta x. Then, once again, you expand out just like usual. Now, you kind of get an idea about how this is going to differ, because when you expand the sine, you get pluses. You get a plus between. When you expand the cosine, you don't get a plus. You get a minus. So maybe that gives us a hint. I don't know. So we've got delta x goes to 0. And now let me expand this out. Cosine x, cosine delta x, minus sine x, sine delta x, minus cosine x. There we go. And I think I can do exactly the same thing that I did before. I'll just put the last term with the first term and give it its own limit, right? So look, here I go. I've got the limit as delta x goes to 0 of cosine x, cosine delta x, minus cosine x. Look how this is working out, all over delta x. Now, you've got to always, when you see a negative, you think, proceed with caution. Slow down, because I've got this minus here, so be careful. Go ahead and put that there. And then I've got the limit. Delta x goes to 0 of sine x, sine delta x over delta x. Now, dig with me, if you will, that I can factor out the cosine. And at that point, I have this limit is equal to 0, right? It's exactly the same as last time. Here I can factor out the sine, and I get negative sine x. Negative sine x times 1. And there we're done. So it looks like what we found is that the derivative of cosine is negative sine. Okay? So close, yeah. Okay. Any questions about that? Okay. So that's how we can find. Now, what we're going to do next time is something called the product rule and the quotient rule. And then we can use that to get the derivative for the other 4 trig functions. Yes, sir.
Is there such thing as a double derivative?
Yep.
Derivative of a derivative?
Mm-hmm.